Road to performance. So in today's episode, we are going to take our .NET API and our PostgreSQL database from choking at 100 virtual users to handling 600. We'll try two different approaches. First, I will implement AddDbContextPool from Entity Framework to theoretically give us better performance by reusing database contexts. Spoiler alert, it doesn't help. Actually makes things slightly worse. Then we'll dig into a real problem, which turns out to be PostgreSQL connection limits. And we'll modify the database configuration to handle 400 concurrent connections instead of 100. We'll also need to rebalance PostgreSQL memory settings because we are running in a constrained Kubernetes environment. Just 1.8 gigabyte of RAM per pod, matching Azure B1 tier. By the end, we'll see a significant improvement in throughput, but the path there teaches us some important lessons about where the bottleneck actually occur. Let's recap our baseline results solution. So we see that we are reaching at the 50 virtual users about 2100 RPS. Then we go to the 2200 at 100 virtual users. And once we are going above 100 and maintaining 100, it significantly drops. And we needed to understand what was going on. The CPU was maxing out pretty quickly, but it turned out that it wasn't the real problem after all. So what was the problem? The problem is the database connections, the 100 maximum connections from Entity Framework to the PostgreSQL. It was saying, sorry, too many clients already. So that was the problem that we faced. Let's take a look on the baseline solution of the writing scenario. We see exactly the same pattern as of the reading scenario. We are hitting the maximum RPS, 2800. Then we go to, we maintain this. And then once we hit 100 virtual users, yeah, it's better now. So now when we hit 100 virtual users, we are dropping down and down to 500, more or less. So I suspect we are having exactly the same issue here. Let's take a look on the CPU utilization. So CPU utilization is also, let's say, 1/3 or a quarter of the time. We see more or less 100% utilization or slightly less. Then we see a little hill in here. Something happened. So maybe this is connected between it. No, it's cannot tell right now. We see that it's not reaching 100% at all. Memory consumption looks good. HTTP response, we see that it's, compared to reading scenario, we cannot assume that's gonna be less than 500 milliseconds because writing generally takes much longer time than reading because it needs to save certain objects to the database, which is slower. So maybe let's say 1 second is going to be fine. So in this instance, 99 percentile takes 983 milliseconds, so more or less 1 second. So in here, it reaches 1 second for entire percentile. So here it's too much. However, let's take a look on the API throughput. So API throughput looks very, very similar, except for this hill. Yeah, so I think what happened, it was a lot of requests came through in here. So that's why CPU started to work. And that's why we have this spike of a CPU because of the many requests per second. But something allowed to let in so many requests. So maybe PostgreSQL allowed it. Throughput utilization looks fine. You can also see the shared tooltip in here between widgets. Garbage collection also seems fine, and HTTP request activity looks good as well. PostgreSQL, we see that it reaches very quickly, or not even maybe. PostgreSQL CPU utilization, we see that it actually hits 100% of utilization. So it's working, it's doing heavy lifting right now, and it cannot do anything more. We see a lot of things in here on this PostgreSQL connections widget. We see that it starts from around 46 connections, and then it goes until 100. So we also see the same problem, which is too many connections at once. It reaches the maximum connections available. So I believe it's because of the available connections to, I believe it's lack of connections. I believe it's a lack of available connections between Entity Framework and our API. That would be the same concern. And comparing this to the reading scenario, it should be the exact problem of that. One of the common recommendations is DB context pooling. Microsoft documentation mentions performance improvements up to 50% in certain scenarios. So I just thought, okay, let's do it. The change itself is straightforward. We replace AddDbContext with AddDbContextPool in our startup configuration. Instead of creating new DB context objects for every request, we maintain a pool of reusable contexts. This reduces object allocation and garbage collection overhead. Let's run the same load test and see what happens. Look, after the fixes, the first fix of the AddDbContextPool, we see that the pattern is probably exactly the same. So we are reaching around 1800. Then we go, we maintain the same ratio, more or less. And then we drop after we reach 100 virtual users, and we drop to 600, 500 RPS. So first thing, I see that comparing to the baseline solution, we actually dropped like 10%. So it means it's slightly worse. But also the original problem which we had is not resolved, because if it was resolved, it would be different pattern, or it would be breaking after 100 or before 100. So I believe this is still the problem. And the CPU looks the same. Memory consumption looks good. It looks funky, but I think maybe this is left over from the last time. API throughput looks exactly the same. So the pattern is for the first 100 virtual users looks the same, and then drops, and then plateau and the very low RPS. Thread pool utilization, nothing to be looking at it. Maybe I'll analyze it in the future, but I believe this is still the problem. And the problem is, again, inside the number of the connections that we can do from our API to the PostgreSQL. So this is unresolved. Also worth taking a look on the number or the CPU utilization of the PostgreSQL cluster or pod. Out of the compact dashboard, it is possible to export data as a CSV. So I did so. I exported that data from the baseline solution and from the first attempt, which is AddDbContextPool solution, and exported this as a CSV. Then I created the dashboard of comparison and applied two sets of data on top of each other. So this is the comparison of reading. Right now we'll be speaking about reading for the first solution. And we see that what I was saying about this exactly the same pattern is true. So request B is actually slightly better than the previous one, but it doesn't change that much the situation. It still is dropping in the same place, so 1800, and then goes to exactly the same place, which is 650, and then goes flat. So this kind of data-driven approach can beautifully show us what's going on in the system and can compare apple to apple and not to guess anything. Especially that going from one dashboard to the second dashboard and comparing data to data, singular metric to metric is quite hard. And when we put this data and normalize it, it's much easier to compare the results. So we see that results of responses are exactly the same. The RPS is more or less the same. It's not a big deal. So it didn't work. That's my assumption. We need to try something else. Let's try different thing. Introducing AddDbContextPool to writing scenario looks like this. So we see the same pattern of going to the maximum RPS, then hitting the maximum RPS in here. And once we go till 100 and above, we are reaching to 500 RPS. So we haven't fixed this issue yet. We see CPU is less than 100, then it drops to about 35%. And what else? We see that API throughput is looking exactly the same as in the baseline of reading and in baseline of reading and baseline in writing. So all of this looks good. We see that it reaches really quickly to almost 100%. So let's check 10 p.m. 21:30. So we see it actually rises to 100, but it's not the problem of the CPU, I believe, and it's not the problem of the connections. At least on the metrics, I cannot see that. But I believe that that's exact problem what we see here. Probably I'm missing something here. I'll try to analyze it later on, why we are missing certain metric and we are not reaching 100% of connections. However, this is exactly the same problem, and it drops anyway, right? So it's really interesting. So yeah, let's maybe proceed to second attempt, because I was based my actions on the reading ratio first and not writing ratio. However, I should be careful about it next time and be cautious. And I should be cautious next time. Okay, and before we proceed, let's take a look on the compact dashboard, and let's take a look. Let's compare baseline solution of writing and the adding AddDbContextPool. We see that values have the same pattern. They are slightly different, actually a little bit worse in terms of writing requests. We see that a drop about 10 or a little bit more percent in RPS. So it actually degraded our performance in writing. However, even it degraded, it helped in terms of reading. It was a little bit better, but both of these patterns are the same. So it means we have still the problem. We still have the bottleneck of API that cannot connect to the database. It cannot create more connections. So it means that database context pool, maybe it will help in the long run, or maybe it will help when we fix the initial bottleneck, but it didn't help right now. So the pattern is the same, but the values are so the pattern is the same, but the values are a little bit different, but they do not matter that much. So we need to find a better way. Now that we know that database connections are the limiting factor, we might think the solution is simple. Just increase max connections from 100 to something higher. But we are running with resource constraints. So it makes this more complex. We need to be careful about, if we want to support more connections, we need to rebalance PostgreSQL entire memory strategy. On the PostgreSQL side, I'm making these adjustments. Max connections from 100 to 400, work mem from 4 megabytes to 2 megabytes, shared buffers from 64 megabytes to 128 megabytes, and effective cache size 1 gigabyte from original 4 gigabytes. And on the application side, I'm increasing the connection pool size from 100 to 300 to match the database new capacity. And this is how it looks after we introduce the second attempt. So we modify the database connections and the memory allocations on the database on the PostgreSQL. So it looks already much different. Why is that? Because we see that it hits to the maximum 2000 RPS, and then it maintains more or less the same level of the request per second. Then it goes even to 2200, and then it drops, and it drops because we are finishing with the ramping down the virtual users. So it's perfectly fine. So until this moment, we reached 600 virtual users, and this is our maximum RPS. So it actually was very successful, and it remediated our initial problem. So the changing the maximum connections actually healed the bottleneck. So take a look on the different widgets. We see the maximum utilization of the CPU on the application level is all the time almost 100%. Maybe this is a problem. Another one. We'll need to take a look in this next place. Take a look on the response time. Response time looks fine, and it doesn't actually hit 500 milliseconds at all. So that was one of our thresholds that I was setting up, and I think it's still good for that amount of RPS. It didn't hit the initial limit. So then we see exactly the same ratios in here as API throughput, which is coming from the throughput from the server side and from the client side. We see the same patterns: throughput utilization, garbage collection, HTTP live requests. Take a look on PostgreSQL. And now we see that PostgreSQL is actually not hitting 100% CPU utilization. So this is good. So I think we went from 100% utilization all the time and using 100% of the connections of the PostgreSQL. And now we are not using 100% of the CPU and also not all the connections. So this is very good. So it means right now, most probably the PostgreSQL is not our bottleneck anymore because it doesn't hit the 100% in all widgets. But we'll analyze this situation in more details in the next episodes, and we'll try to go even further and further with the numbers. Yeah. And now we can compare the three runs. So the baseline, the AddDbContextPool, and also modifying connections of the PostgreSQL and memory settings. So this is A, B, and C. We see that the C, so the third run, is the best. It doesn't have this problem of after 100 virtual users was going down to 600, 500 RPS. It actually maintains more or less the same level of RPS. When we hit 600, it actually even goes to, so we even see the 2200, which was not even on the first stage. So it looks beautiful. After second attempt, after we modified the database connections and modified memory settings, we see totally different pattern here. We see that it reaches 2800. It goes to 50 virtual users, to 100, 200, 300, 400, 600. So we went through entire test. We don't see that significant drop of RPS. So it's much more stable. It can handle all of it can go through the entire test load. So it's looking much better. It's actually looking good now. Yeah, so let's have a look on the different widgets. CPU utilization, we can see that it goes to 100 and then slightly goes until lesser and lesser numbers. And what I can say right now about it is that CPU performance is not the primary resource of a problem of why it cannot be higher number. So I believe this is it's being blocked by something else. Memory looks good to me. Response time looks very good. The response times haven't even crossed 500 milliseconds. And API throughput, to me, looks alike to client-side RPS. Throughput utilization, I need to take a look. I need to familiarize myself. What is the maximum number of the thread pool utilization? Maybe this is 100. I'm not sure if this is percentage or this is some specific number, but I'll take a look. Garbage collection, I see that it's going to 78 milliseconds, 80 milliseconds, and it's getting a lot, or maybe a bit to me. It's looking suspicious to me. So I need to take a look. And let's go down to PostgreSQL. And I believe this is the problematic part. CPU utilization looks like it's going to maximum capacity all the time. But I believe this is the problem. Okay, and this is the resource that probably could be worked on. So the connections of the PostgreSQL. And let's have a look how we can make it better. And let's compare this one from the previous results. Writing looks that RPS is the same for the for the first and the third run. So we haven't changed significantly the RPS. However, after 100 virtual users, it doesn't have this problem. It still goes flat. It still goes really good. However, it a little bit drops for 2800 RPS to 2100 RPS. So I think there's still room for improvement for this API and PostgreSQL, and we will be testing more and more solutions, and we'll try to test the limit to the maximum and for the resources that we've got. So Azure B1 tier, I don't want to change that. Alternatively, I want to go horizontal, not vertical. So let's have a look what kind of level of RPS we can maintain. That's everything for today. We successfully scaled from 100 to 600 virtual users for both read and writes. Read operations maintained 2200 RPS throughout the test. Write operations sustained 2100 to even 2800 RPS with no connection bottlenecks. If you want to see more videos like that, leave a comment, a subscription, or a like, and it will help me a lot producing this. Thank you so much.